So welcome back to Heritage Tutorial. If you check the previous videos, we've done justice to limits of a function. So now we'll be going directly to differentiation. And under differentiation, we believe that you already read the normal differentiation that you need to know. So basically, what I'll be taking is just short methods of how to get these things, all these topics in preparation for your exam. You have function of function, you have product rule, you have quotient rule, you have implicit differentiation, logarithmic differentiation, then inverse of trigonometric and hyperbolic functions. So, for example, the first one, under function of a function, you can have a function that says 2x plus, okay, let's say 2x squared plus 5x plus 3. Okay, everything raised power of 3. So you have to differentiate this function. Normally, the standard way of doing it is you let this one be equals to u, then you write a formula that says dy dx is equals to dy du multiplied by du dx. But now we'll not be using that same formula here. So we'll only be taking the short method. And the short method is that differentiate what is inside here, multiply it by this power, and rewrite this, subtract this by 1. If you don't get what I said very well, I said differentiate what is inside this place. Whatever function you have been given, differentiate it, write it, multiply it by this power, then rewrite this and put the power minus 1. So now, when you differentiate what is inside here, 2x squared, differentiate 2x squared, you have 4x, then differentiate this, you have plus 5. Don't forget that I said multiply it by this power, so this power is coming here. Then open another bracket. Differentiate what is here. Sorry, rewrite what is here rather. 2x squared plus 5x plus 3. Then subtract 1 from this power. Let me come back again. I said that write this power here, then differentiate whatever is inside the bracket. That is the function you are given. So when you differentiate 2x squared, you have 4x. Don't forget this 2 will come to the side. 2 times 2, 4. Then x, 2 minus 1, that's 1. Then plus 5. Differentiation of 5x is 5. Then rewrite this whole thing here. Then subtract 1 from the power. So that's the answer for that. Let's take another example for that. Y is equals to sine square or sine raised power 3 of x. So when you are given a question like this, the same thing. You all know that sine cube of x is the same thing as saying sine x everything raised power of 3. So like I said, let this power come to the side. So when you differentiate your dy dx is equals to this 3, let it come to this side. Open the first bracket. Differentiate what is inside that bracket, the function itself. So when you differentiate sine x, you have cos x. Then open another bracket, rewrite this sine x, then raised power of 2, 3 minus 1. So now open this bracket up, you have 3 cos x sine square x. So that's that for differentiation of function of a function using the shortcut. This is the first question and the second example. Thank you very much. Okay, so this is the third example under function of a function. When you are given an exponential function and you are asked to find the differentiation, note that from the normal differentiation of exponential x is still exponential x. But in this case, it's not x that is here, it's 5x squared plus 2x. So when you're asked to differentiate this, like I said, we are only taking the short method in preparation for your exams. So if you are given a question like this, you differentiate whatever is at the exponential, whatever function that is there, you differentiate it. So when you differentiate that, differentiation of 5x squared is 10x plus differentiation of 2x is 2 in the bracket. Then you rewrite the question again, exponential 5x squared plus 2x. So it says that differentiate whatever is here, write it here, then rewrite the question. That's the short method for differentiating exponential function. Thank you.